Alright, in this video here we're going to talk about evaluating trig functions when our angles are measured in degrees instead of radians. Now I've done other videos where I talked about how to evaluate trig functions when we had radian measures. Here we're going to talk about degrees. So the first one we're going to have here is sine of 225 degrees. Now if you didn't watch the other video that I just did about special values of the trig functions and like the unit circle with degree measures in there, you should probably check that one out before you see this, just so you understand where I'm coming from here. But if I want to do sine of 225 degrees, 225 degrees looks like one of the numbers I've seen on the unit circle. So let's see. So here's 0 degrees, 180 degrees is over here. If I add 45 degrees to that, that's going to be 225 degrees, right? So the angle here, from the positive x-axis around and then halfway through the third quadrant, that's the angle of 225 degrees, right? It's 180 plus another 45. Right, so to figure out the terminal point on the unit circle for 225 degrees, well, since it's right in the middle of that, that third quadrant, it's going to correspond to the terminal point for 45 degrees that's over in the first quadrant, which also corresponds to pi over 4, if you remember the stuff we did with radians, using your trig hand. So root 2 over 2, root 2 over 2. Right, if you don't know what I'm talking about when I say trig hand or what I just did with my fingers there, I would advise you to watch the video that I did about the unit circle and using trig hand so you can see what I'm doing there. So that's my terminal point for 45 degrees in the first quadrant. So if I reflect that point over into the third quadrant, both of my coordinates have to be negative. So it's negative root 2 over 2, negative root 2 over 2, and the sine, if I'm using the unit circle, the definition of the sine function is the y coordinate. So sine of 225 degrees is going to be negative root 2 over 2. All right, so that's how we can use that unit circle. When I talked about the unit circle in other videos that I've done, it was always in terms of radians, but we can do it for degrees as well. We just have to locate, whether this angle in degrees is one of the numbers I have on the unit circle, and if it is, I do it just like I did before with radians. It's actually a little bit easier with degrees because it's easier to locate where those angles are using degrees than it is with radians, for most people at least. All right, the next one here, cosine of 150 degrees. All right, so 150 degrees also looks familiar. I think I've seen that on the unit circle. Once again, halfway around the circle is 180 degrees. 150 is going to be 30 degrees less than that. Right, so here's my angle of 150 degrees, right out to here. So I need to find the terminal point on the unit circle that corresponds to 150 degrees. Well, if this is 30 degrees above the x-axis over here, right, 180 minus 30 gives me 150. Well, if I do 30 degrees on this side, right, that corresponds to pi over 6. That corresponds to my ring finger on my trig hand. The terminal point is root 3 over 2, comma 1/2. All right, so if I reflect that point over into the second quadrant, the x becomes negative, so it's negative root 3 over 2, positive 1/2, right? In the second quadrant, x coordinates are negative, y coordinates are positive. And the definition of the cosine function is my x coordinate of my terminal point. So cosine of 150 degrees is going to be negative root 3 over 2. Right, so a couple quick examples here of how we can use the unit circle to evaluate trig functions when we have degree measures instead of radians. Right, so all the stuff that I did, if you haven't seen the other videos that I did about the unit circle and about the trig hand and locating the terminal points and all that, you should definitely watch those. Where I do the same thing that I did here, but I do it a lot slower and I explain it in a lot more detail. But since I've already done that so many other times, the only difference here is that we have degrees instead of radians. But still, once I locate where that point is on the unit circle, I do the same thing that I did with radians. I just find the point that corresponds in the first quadrant, and then take those same numbers and reflect them over and change the positive and negative signs if I need to. All right, so there's a couple examples. I'm going to pause the recording here and then put up a couple more examples that we'll do with degree measures. All right, so the examples I put up here now, tangent of 40 degrees, cosine of 20 degrees, cotangent of 14 degrees, cosecant of 80 degrees. Now, one thing you might notice about all of my degree measures here, none of those actually appear on the unit circle, right? Again, I did a unit circle video not too long ago where I talked about the degree measures around the unit circle. And if you recall, in the first quadrant, the degree measures I had were 0, 30, 45, 60, 90. Right, well, 40, 20, 14, 80, none of those are the ones I just named. Right, so if I want to evaluate these trig functions for these angle measures, I'm not going to be able to use the unit circle. I can only use the unit circle if I have 0, 30, 45, 60, 90, or whatever else I get as I go around the circle, following that same pattern. If my numbers don't apply, then, or if the numbers I have are not on the unit circle, I have to use a calculator. Now, if you've been following along with the other videos I did of trigonometry, previously I said your calculator has to be in radian mode in order for things to come out correctly. But now that our angles are being measured in degrees, to do tangent of 40 degrees, I have to make sure my calculator is in degree mode, otherwise it's going to give me the wrong answer. Right? If I try to do cosine or tangent of 40 degrees and my calculator is in radian mode, it's going to come out wrong. So to change the mode, on my calculator, the mode button is up here next to the second. So I hit that mode button, and you can see the third one down says radian and degree. And right now my calculator is in radian mode. So I have to scroll down and then over to degree and hit enter so that it highlights the degree mode. And now my calculator is in degree mode. Now I can just press some buttons and get the answers to all of these. Right? So from this point forward in trigonometry, some problems are going to be with degrees, some problems are going to be in radians, so you have to be paying attention to those details and make sure your calculator is in the proper mode. Right? Any scientific or graphing calculator will have a radian mode and a degree mode. The way you change the mode, if you have a different type of calculator, it's probably going to be a different way to change the mode, but there's some way to do it on your calculator, so figure out how that is. Look it up online if you can't figure out how to do it on your particular calculator. But you have to be able to switch back and forth easily, and you have to pay attention to each individual problem so you know which mode you're supposed to be in. Right? General rule of thumb, if you see an angle with that degree measure there, make sure your calculator is in degree mode. If you don't see that, then you should probably be in radian mode. Right? All right, so tangent of 40 degrees. So once again, I've done this before for radian measures, but just to go over it one more time with degrees here, right? Right in the middle here, I have the sine, cosine, and tangent buttons, and I'm hitting a button by accident there, right? So I have sine, cosine, and tangent. So to do tangent of 40 degrees, right, I hit that tangent button right there, and then I type in 40. And since my calculator is in degree mode, it gives me the tangent of 40 degrees, which works out to be 0.839099. So let's call this about 0.839. All right. Now, just to show you real quick what happens, I'm going to go back and put my calculator in radian mode, just to show you what happens if you don't change the mode. All right, if I go to radian mode and I do tangent of 40 degrees, I get negative 1.117. Totally wrong answer from what I got here. Right, so very important that your calculator is in the proper mode. Otherwise, I guess there's a chance that sometimes it might come out to the same value, but the chances of that happening are extremely rare, extremely low chances. So I would advise not taking the chance. Make sure your calculator is in the right mode. All right, cosine of 20 degrees. All right, calculator is still in degree mode. I just switched it back. So cosine 20. Let me double check. I did switch it back. I just want to make sure. I would look like a fool if I didn't switch it back. All right, so cosine of 20 degrees, and I get 0.93969. All right, so cosine of 20 degrees is about 0.93969, let's say. All right, so that's cosine of 20. Next one, cotangent of 14 degrees. Well, my calculator has a button for sine, cosine, and tangent. It doesn't have buttons for cotangent, cosecant, or secant. Right, so in order to do those other three trig functions in my calculator, I have to use the reciprocal properties. And this is also something I've talked about in other videos that I've done about trigonometry. So if you're not familiar with these reciprocal properties, go back and look at some of the other ones I did about the trig functions. But cotangent is the reciprocal of tangent. Right, so cotangent of 14 degrees is the same as 1 over the tangent of 14 degrees. Right? And while I'm here talking about it, cosecant is the reciprocal of sine. So cosecant of 80 degrees is going to be 1 divided by the sine of 80 degrees. Right? And then the secant function is the reciprocal of the cosine function. Right? We don't have an example of that here. But if you have to do secant, it would be 1 divided by cosine of whatever your degree measure is. Right, now, just one thing to point out. All right, so the first one I'm doing 1 over tangent of 14 degrees. Notice above my tangent button, it says tan negative 1. That doesn't mean tangent to the negative 1 power or 1 divided by tangent. That means the inverse tangent function, which is something different than the reciprocal of tangent, right? So when you have to use these reciprocal properties to evaluate these trig functions, you actually have to type in 1 divided by tangent 14, right? So 1 divided by tangent 14, hit enter. So cotangent of 14 degrees is 4.01078. All right, so there's my cotangent of 14 degrees, which corresponds to 1 divided by the tangent of 14 degrees. And then for cosecant of 80, that's going to be 1 divided by sine of 80 degrees, right? So once again, 1 divided by, and then sine of 80. Hit enter, and I get 1.0154. All right, so using your calculator to evaluate trig functions, you do it the same way, whether you're in radians or degrees. The same buttons on the calculator apply. You have to use the same reciprocal properties for these, cotangent, cosecant, and secant functions. All right, so you do it all the same way. The only difference is if your angle measure is in degrees, you got to make sure your calculator is in degree mode. If your angle measure is in radians, you got to make sure your calculator is in radian mode, right? If you're able to do that part, the rest of it is just typing the stuff in your calculator, and that's pretty simple. All right, so that's using our calculators to evaluate these trig functions.